Okay, this is going to be page 263 to 264. So going through, we're talking about the cross section. So if you were to cut the three-dimensional figure, what would it look like? So it says he's baking cookies. Joaquin's baking cookies using cookie batter formed in the shape of a cylinder. How could you cut it to make a circular cookie? So they're saying you cut right here, you have a circular cookie. Suppose he wants to make rectangular cookies. How could he cut the dough to make it rectangular? So he could cross it perpendicular, so he could cut across. Okay, so let's say he could cut a cross section that's perpendicular, because this is the one that's parallel, perpendicular to the base, because that's the base right here. Okay, so that's how I would describe that. It says he reshapes the dough into another three-dimensional shape where he could have a cross section. What could he have made? So I think of an ice cream cone, right? So I would probably just say a cone. He could make a cone. Okay. When you cut a cross section of a three-dimensional shape, how many dimensions is a cross section? So we're looking at a three-dimensional, but when you cut it, you get 2D. You get two-dimensional. 2 dimensions, because it is a plane figure, okay? We're talking about plane figures. Plane figure once it is cut. A cross section taken of the cube is known or shown as a triangle. Describe how the cube could be sliced. So the only way to slice it would be to make a triangle is to slice it right across like that. Okay, so describe how it could have been sliced. The cube could be sliced by the corners to make the triangle. So we're explaining it that way. I showed it this way. The other way, if it was like this, was you could just say you're cutting off these corners right here. Cut, cut, take those out, and then you would have a triangle as well. Okay, both of those ways would work. 5, it says use the information below to solve these problems. So a concrete block, like the one shown here, is used for concrete posts. The top and the base are squares. So this is a square. This is a bigger square. Okay. What shape results from if you were to cut horizontally? Okay, if I were to cut horizontally, it's still going to be a square. Square, and I just make myself a little square because it says name and sketch the shape. What happens if you cut it vertically? So you have to think about, if you're cutting it this way, what that looks like. It looks like this, which is this shape, oops, which is this shape, which is a trapezoid. Okay, she cut several cross sections from the rubber ball. How would the cross sections be alike? So if you have a rubber ball like this, okay, and you cut cross sections, how they're alike is you're going to get a bunch of circles, right? This will still be circles. Okay, they all would be circles. But how would it be different? Look at this. They would be different sizes of circles, okay? The circles would be different sizes, okay? Ken says he can produce 4 different plane figures from slicing a square pyramid. All right. I must be talking about a square pyramid like this. If you slice it horizontally, you're going to get a square. If you slice it wait, if you slice it this way, you're going to get a square. If you slice it this way, you're going to get a trapezoid or a triangle because it's a pyramid. So triangle, square, triangle, square. And if you slice it through the side like this, it's trapezoid. So but that's it. There's really nothing else. So he said you can get 4, you can only get 3. No, he can only get 3. The parallel cut, that's what we'll call it, is a square. The perpendicular cut is a triangle. The side cut is a trapezoid. That's only 3 different plane figures. Alright, that's going to be 263, 264. Let's go ahead and look at 265 because you're studying the example and you're underlining 2 parts that you make it a good answer and helpful. So it shows your work. If you slice the 2 figures parallel, the cross sections will both be circles. So if I do it parallel, then I would get circles. Because I would cut it like this. But if you do it the other way, you would get these. Okay, so it's important to me to see that I'm going to circle and underline. It's important to me to realize you have to draw the figures. The cross sections is important to me to explain, and the cross section, so perpendicular and parallel. So I have to talk about perpendicular and parallel. So I have to have at least like 3-4 sentences, and I have to draw it out. Okay. The same slice was made through 2 3D figures. All right. So a 3D figure. So and the top looked like this. Let's get 3D all over here. Pretty terrible 3D, but it works for what we need it for. And then the top of that one looked like that, so that's just a rectangular square. I don't think we're gonna get any points for drawing, but luckily we don't get judged on that. Okay, name and sketch 2 solids that could be sliced to produce their cross sections. Okay, so we have to talk about perpendicular and parallel. So when the figures are sliced parallel, then the figures are this is parallel. Parallel is like this, so you get a triangle and a square. Triangle and a square. Perpendicular. When the figures are sliced perpendicular, the shape, the cross section is a rectangle. All right, so then did we answer the questions? It says use in words and diagram to explain your answer. It matched here, it matches here. We named and sketched 2 solids and described how they were sliced. Yep, so that works. That's going to be, now you have the information for 263, 264, 265, and 266.